Okay, line 22, 7B121, Big Bang Theory, Dark Matter Nebula NGC 2392, Cold Hot Theory, Wow Seti. There's the alien radio signal. There's the thing there. So this is hydrogen ions, NGC 2392 Nebula, cold dark matter particles act in my Big Bang Theory plus dark matter particles, Higgs electric field particle formation, and formulas found in the WOW data line 22. I gotta make sure this isn't a formula. No. Kind of is. No, that's not a theory. It's keyword research. Okay. I just wanted to make sure it wasn't a theory. Sorry about that. So line 22, 7B120, Higgs dark matter Big Bang Theory, Hydronium, ion comets, WOW Seti. December 9th, my thoughts. Hydrogen ions to nebula. I wanted to know how it interacts and if it will prove my theory of the Big Bang plus dark matter particles, and yep, it does. Several videos on how I think the Big Bang Theory exists and how it did it. So here's a composite image of the planetary nebula NGC 2392. Credit from X-ray NASA CXC, IAA and CSIC, and Roots AL, Optical NASA STScI. And hopefully you know what all that means. So using data from NASA's Chandra X-ray Observatory and Hubble telescope, astronomers studied NGC 2392 and two other planetary nebulas with hot gas in their center, revealing that NGC 2392 has unusually high levels of X-ray emission compared to the other two. Instead, planetary nebulas form when a star uses up all of the hydrogen in its core, an event our sun will go through in about 5 billion years. When this happens, the star begins to cool and expand, increasing its radius by tens to hundreds of times its original size. Eventually, the outer layers of the star are carried away by the thick 50,000 km/h wind, leaving behind a hot core. This hot core has a surface temperature of about 50,000 degrees Celsius and is ejecting its outer layers in as much faster wind, traveling 6 million km/h. The radiation from the hot star and the interaction of its fast wind with the slower wind creates the complex and filamentary shell of a planetary nebula. Eventually, the remnant star will collapse to form a white dwarf star. A paper describing these results was published in the April 10, 2013 issue of the Astrophysical Journal. The first author is Ruiz of the Institut d'Astrofísica de Andalucía, IAA-CSIC, in Granada, Spain, and the other authors are Yu Ha Chu and Robert Groville from the University of Illinois, Urbana, Martin Guerrero from the Institut d'Astrofísica de Andalucía in Granada, Spain, and Ralph Jacob Detlef Schomburger and Matthias Steffen from the Leibniz Institute for Astrophysics in Potsdam, Germany. NASA's Marshall Space Flight Center in Huntsville, Alabama manages the Chandra program for NASA's Science Mission Directorate in Washington. The Smithsonian Astrophysical Observatory controls Chandra science and flight operations from Cambridge, Massachusetts. Publications in Roots al. Detection of diffuse X-ray emission from planetary nebulae with nebular OV. Diffuse X-ray emission from planetary nebulae with nebular OV. Source J.D. Harrington, NASA, and that's the image information. And it's from scitechdaily.com is the link. So my thoughts. Remember, we find hydrogen in the core of this nebula. This is important to remember with my Big Bang Theory calculations in later videos found in the WOW data line 22. The star uses up all hydrogen in its core. Star cools, expands, ultra-cold atoms. Do they expand and add mass? There is a formula. I knew it. Sorry. Star increases radius, tens to hundreds of times original size. Outer layers of star are carried away, thick solar wind storm. Earth's crust is like dirt. Dirt is carried away in the wind, leaving behind a hot core star. Surface temperatures are 50,000 degrees Celsius. And ejecting outer layers, can't spell, sorry, layers, jet streams, and then much faster wind traveling 6 million kilometers per hour, radiation from a hot star, interaction of fast winds with slower wind created complexes of elementary shell of planetary nebula. 2 atmospheres on Earth. There's a higher ones and a lower ones. Okay, so we have Earth, we have a troposphere, stratosphere, mesosphere, and thermosphere. So we actually have 4. But you see the amount of kilometers they have? 17, 8, not 50, and 80 kilometers. Same thing in a star nebula planetary formation, only the ones are higher rates of speed. It collapses the remnant star and forms a dwarf white star. So the keyword to Google will be dwarf white star, and this is what it looks like. This is the image of Sirius A and Sirius B taken by the Hubble Space Telescope. Sirius B, which is a white dwarf, can be seen as a faint pinprick of light to the lower left of the much brighter Sirius A. So this little tiny dot here, if you can see it. See, I'll go a little closer there. See that little dot down there? So the bigger one's A and the little one's B. Sirius A. So there's a faint prick of light to the lower left of the much brighter star, so Sirius A is brighter. Quote from Wiki. A white dwarf, also called a degenerate dwarf, is a stellar remnant composed mostly of electron degenerate matter. They are very dense. A white dwarf's mass is comparable to that of the Sun, and its volume is comparable to that of the Earth. In fact, its faint luminosity comes from the emission of stored thermal energy. The nearest known white dwarf is Sirius B, 8.6 light years away, the smaller component of the Sirius binary star. December 9. The data continues about the Big Bang Theory plus dark matter and how it forms nebula and planets Earth. In the next several videos. There you go. Thanks for watching.